And before I do anything else, I just want to thank Keith Goulding for chairing this morning's session. I've not just got a hard act to follow, I've got an impossible act to follow, not least because we were already 3 minutes late. But I must say, and also I'd just like to say, I felt that the discussion we had this morning and all the speakers was one of the most interesting and important discussions I've ever participated in, and I'd like to thank you all again for coming and for contributing to it, because we've got such a fascinating diversity of interests here, and I just felt that all the interventions and all the speakers were brilliant and inspiring and challenging in equal measure, and as a result something really important is happening. So thank you very much, and also thank you again to the sponsors for making it possible. I was supposed to, at the beginning of the lunch, to just mention the story behind the lunch, because you might have noticed that we had grass-fed beef, actually from Kite's Nest Farm, Richard's Farm, and all the ingredients were sort of sustainably and locally sourced in one way or another. And this was our attempt, in a very subtle way, to suggest that what we eat and the story behind it actually is one of the important ways in which our food systems can change once we understand what on earth it is we're supposed to eat, which of course is one of the themes that was explored in the lunchtime discussion. So we're going to come back to that with some reporting of the key messages, or the key sort of conclusions, if you drew any, that arose from your, is it 5? Yeah, the 5 tables and all the themes that were discussed over lunch. But we're not doing that until 4 p.m. So now we're going to launch into the afternoon programme, and it's my pleasure to, the theme now for this first session, and there are 4 speakers followed by discussion. So we've got an hour followed by discussion. Each of the speakers has got 15 minutes. And our first speaker is Professor Ian Gibbons from the University of Bristol.
Reading.
Sorry, Reading, can't read my own. And the theme is, sorry about that. So, since I can't follow Keith, I've demonstrated in the first introduction. Milk and dairy products, dietary partners for life. And it's 1:35, so we'll have to give you the 15, and we'll continue to do that.
Okay.
Over to you. Thank you.
Thank you very much, Mr. Chairman. Good afternoon, everyone. It's a great pleasure to be here, and I'm very grateful to the organisers for the invite. I have to say I feel a little bit of a fraud, in the sense I'm not going to say anything about sustainability, but hopefully there'll be 1 or 2 messages in there which I think will eventually connect to it, and you'll see that the university has kindly produced slides in a nice green colour, so we've got at least some greenness. What we're really talking about here, or what I'm going to talk about here in the 15 minutes or so, is really the impact of consuming dairy products on health, but particularly on health across the lifespan. This is sort of a theme that we have at Reading, really, not just for dairy products, but other foods as well, and really looking at the long-term exposure, childhood, during pregnancy, which I'll mention briefly later, over the long period of time, and what is the very long, my battery's gone, what is the very long-term effect, if you like, on health outcome. And of course there's a variety of health outcomes we could be interested in. The main focus, I have to say, that for us at the minute is cardiovascular health outcome, but there are others as well. So that's roughly what I'm going to talk about. And I just want to pick sort of 4 or 5 examples of things that are going on at the minute which have an impact in the UK, so it isn't really extending much beyond, well, within Europe anyway. And just to say, of course, that it's all very well looking at these long-term associations. Long-term associations do not tell you cause and effect. They are what it says, they're associations. So you have to dig beneath the surface as well to try and understand the mechanisms, and that's obviously something we're trying to do now, to get the mechanisms as well. I thought I would just start with, probably an obvious thing to start with really, is the contribution that milk and dairy products make to nutrient intake. I'm not going to spend a lot of time on this, but just to highlight one thing which I think is not that well understood, and this is the issue of nutrient density. What we've done on here is to compare meat and meat products with milk and milk products with cereal and cereal products. So the 3 large food groups, and I know there's obviously great variability within them, but you can see, you could if my pointer worked, you can see that in terms of calcium, phosphorus and magnesium, which are just some examples I've put in, important examples, you can see that the dairy products, milk and dairy products, have vastly greater nutrient density. And nutrient density is defined as the amount of an individual nutrient per unit of energy that that food also supplies. So in other words, if you want to put it another way, you can provide the same amount of calcium from milk and dairy products with a lot less energy consumed than you could from the other food groups. And that's I think, an important issue. You'll also notice that in terms of sodium, it's the other way around. And of course there is a campaign, as I'm sure you're aware, to reduce sodium intake, or at least to reduce salt intake, it's primarily a sodium effect. And it so happens that milk and dairy products have a low sodium density, which you could argue is good. And I'm sure you're aware that in terms at the minute, just to take two examples, in terms of calcium and phosphorus, at the current consumption of dairy products, which, as I'm sure you know, is generally a fair bit lower than it was sort of 10, 15 years ago, we still get about 60% of our reference nutrient intake from milk and dairy products. So they're a really big, important supplier of those nutrients and other nutrients, which we could talk about as well as lots of other examples. There's some important ones, and I want to come back to talk about calcium in a minute. And indeed now, because I wanted to very quickly skip to two issues related to young people. And you'll see that young people range from children to pregnant women. In terms of children, this is the current situation that we have with calcium. This is children between the ages of about 7 and 19, 20 roughly. A very, very important stage for bone development. A lot of bone development going on in that phase. Peak bone density, of course, isn't reached till about the age of 30, but bone development, bone elongation, it's a really, really important stage. And you can see that if you look at the RNI for calcium, rises very rapidly after the age of about 6 for reasons related mainly to bone development. Peaks at about sort of 16, 18, 19, and then tails off a bit. And you can see there where we have, you can't see with this anymore, you can see that the mean intake actually is lower than the RNI in that age group between about 8 and 18 roughly. And that's a worry. And you might ask, what is the reason for that? I think the reason for that is pretty simple. If you look at the effect of age has on milk consumption, you can see that in this middle age group, particularly in females, milk consumption declines very rapidly after about the age of, unfortunately the ages on there don't tie up exactly with the ages on the graph, but you can see from the age of 10 on that graph, it declines very sharply. And then even after 19, in females, it doesn't really recover anywhere as much as it does with males. And I think the reason that we see this is because of that. And one of the worries about that is that there's quite good evidence now that consumption of milk during childhood, or childhood and adolescence actually, is related to bone health, if that's the right word, in much older age. And this is a study which was done a few years ago now, looking at milk servings of milk in childhood and the fracture occurrence basically in postmenopausal women. You can see as milk consumption declines from left to right, the risk, the prevalence of bone fractures rises quite markedly by about a factor of twofold rise in the risk, the relative risk of osteoporotic fractures. And that is a worry. At the minute. There are other issues about that as well, which I could mention. I think there is just very briefly to mention is we're also living in an era of suboptimal vitamin D status, and obviously that has a big impact also on the calcium utilisation and bone development. Switching quickly to pregnant women, quite a number of studies now, mostly I have to say by our colleagues in the University of Surrey, which have showed substantially a sub-iodine status. Now this is not like what iodine deficiency used to be in the old days, where people got very thick, the typically thick necks, etc. This is a suboptimal status. It's not overt deficiency. But what they've also shown in the ALSPAC study, which was published in the Lancet last year, I think it might have just been the year before, that they have an association between iodine status in pregnancy, in early pregnancy particularly, and cognitive development of the children. And it showed that from the children from the parents, from the mothers who were most suboptimal, had a poorer cognitive development in the sort of ages of between 6 and 8 when they were tested. Nobody really knows, I think, if you go to age 12 or 14, whether they would catch up or not. But that is a worry. And we've had quite a lot of interest in this, and we've had phone calls from the Food Standards Agency and stuff saying, does that mean nowadays that milk has less iodine than it used to? Because milk is the primary, it represents about 40% of the iodine intake across the population, 40%. And you can't really see much evidence for much change in recent years, but what we have of course seen is the reduction in intake of milk in that young age group, and I think that's the main issue. One issue that has emerged from all of this, which I'm sure you're all familiar with, is the organic story. And Sarah Bath from Surrey showed that in summer milk, organic milk had about half the iodine concentration of, if you like, normal milk. This is our own study just being accepted for publication. This is winter milk, and basically you can see the same thing. With conventional milk, Channel Island milk as well, is getting on to not quite double like it was in the summer, but certainly significantly higher in iodine than organic milk. And interestingly, branded organic milk was not significantly less than the organic, but it was getting towards it. Another curious thing, which we don't know the answer to, is that we also looked at UHT milk. I should have said this was a large-ish retail study. You can see UHT milk is emerging more or less like organic, and we've talked to a lot of people about that, the milk processors, etc. Nobody has come up really with a satisfactory explanation. But of course we didn't in this case have the milk before UHT and after UHT, and we're doing that actually at the minute. But it's not really a problem. I don't think the organic thing and the UHT thing is a problem, at least not at population level here, but it could be an important thing at individual level or at family level. The other thing that I could harp on about, if you like, is I'm nearly there. The thing I could harp on about is the fact that if you look at the way that milk consumption, particularly in childhood, has declined, milk has more or less been replaced almost millilitre by millilitre and more with sugar-rich beverages, and people argue about whether that's contributed to childhood obesity. I think it probably has, but there's absolutely no doubt, I think, emerging that consumption of sugar-sweetened beverages is associated, particularly in childhood, with the development of type 2 diabetes, which, as I'm sure you know, is a progression in the metabolic syndrome, so-called, and increases the risk of cardiovascular disease as well. So that, I think, is also a worry. What is interesting is, however, of course, if we look at this study, it shows quite clearly that increased consumption of soft drinks was associated with a greater risk of type 2 diabetes, metabolic syndrome, which is part of that. But consumption of cheese actually has moderated that, and cheese is becoming quite interesting. There's certain things about cheese which only come emerging now, and this is one of them, which suggests that if you drink loads of soft drinks and eat cheese, you might be better off. But I think the jury is out on that. It's only one study that I've seen on that, but it's interesting. And then finally, when we get to middle age and older, we start worrying about things. And one of the things I just wanted to highlight was this is a meta-analysis we published over 3 years ago now. It has been updated, but the picture isn't really very different. And this is the long-term association across a whole range of different studies that we brought together in relation to milk consumption and cardiometabolic disease in general. And just very quickly, you can see in terms of ischemic heart disease, we have a total of 4.3 million person years in the study, and a relative risk in high consumers versus low consumers was 0.92. In other words, nearly a 10% reduction in risk. And I just wanted to highlight stroke, where we nearly always find in most of the studies that the risk of stroke is greater, if you like, is reduced even more than for heart disease. And we think the main thing that's occurring in these effects is due to the moderating effect of milk proteins, particularly in relation to blood pressure. It's good evidence that milk proteins can moderate blood pressure in a very similar mechanism, actually, to what most blood pressure medications do. More or less, finally, when we get even older, we have an increased issue in old people. This is predominantly people above the age of 80, but it can be earlier. And this is the very severe loss of muscle mass. The muscle mass decline starts at about age 30, so it's not. It happens, but in very old people, it can, in some instances, be very rapid. And you can see what happens. This is a cross section through a thigh. You can see on the left a young thigh, which is high in muscle. You can see the connective tissue and adipose tissue around it. And then on the right, you can see a one that has progressed with more infiltration of fat, etc. And basically, the muscle is less strong. And one of the consequences of that is that if somebody like that has a fall, they're much more likely to break bones than if they had more muscle protection. And there's been a lot of work on this. Mostly, I have to say, in the University of Maastricht, we work quite closely with, but looking at the possibility of milk proteins and other proteins actually reducing the loss of muscle mass. And this is just one study which compares consumption of milk with consumption of whey powder with soybean protein and a carbohydrate placebo. And you can see that the increase in muscle mass is maximum with the whey protein, and I think there's quite a number of studies now which suggest whey protein is more effective than casein, it's more effective than casein and hydrolyzed casein, and it's more effective than most of the so-called vegetable proteins. And that ties in, of course, with the fact that a high proportion of whey produced nowadays goes into the sports industry. The other thing I should just say, and the reason for the clock there, is that it's really important for the protein to be timed. The best effect is if there's some resistance exercise, even in very old people, some resistance exercise, and then the protein is consumed in the recovery period. And the effect in terms of muscle regeneration, if you like, is much greater than if it's not in that period. And that's what happens if you do it. So finally, just to finish, one or two quick conclusions, if you like. Is it a dietary partner for life? Well, it has high nutrient density. The reduced consumption in early life is beginning to be a worry. Method of production can clearly influence the content of some nutrients, and you're going to hear more about that, I know, in a minute or two. But we don't know everything, and I think this is really important. We shouldn't. There's much less information on the relative effects of butter, cheese, yogurt, etc. And also, is fat-reduced milk healthier than full fat? About 80% now of liquid milk consumed is fat-reduced. Why is that? Is not based on evidence. Is saturated fat-reduced milk better than normal? There's some about. And there's still some lingering issues which we haven't had time to talk about, particularly in relation to prostate cancer. That evidence does suggest a slight increase in risk in high consumers. Men, of course, not women. And so the answer, I think, to the question is that for most people the answer is probably yes. And milk, actually, we think is very much misunderstood. And I just wanted to finally say, it's one or two people you might not recognise that are involved in all of this. Thank you very much. The only thing I just wanted to finish to say was that if you're thinking of issues around sustainability, then bear in mind what you wish for, because particularly in relation to milk, as milk consumption declines, things start to happen that you wouldn't predict just from nutrient balance, if you like. There's bioactive compounds in there, particularly the proteins, which may be difficult to replace without them. Thank you very much.
So my research has been all about developing natural forage systems to improve the quality of ruminant products and also performance. And this research is based in three areas. First of all, systems-based research on actually the forage, actually how we graze that forage, how we produce that forage, and also linking with plant breeders about saying, it's not just about growing this grass, this is going to be fed to animals. Let's look at nutrients and breeding strategies which will improve animal performance. And we've got an excellent link with the plant breeders down at Ibers. Animal performance, looking specifically at genetics, the correct animal for the correct system. There's a big difference between our traditional breeds, the slower maturing breeds, and the more continental, fast maturing breeds. And getting the finishing systems correct for the correct type of genetics. And then finally, all about product quality. Actually, let's be proud about the products we produce and the impact that they have in human health. So, my thunder was completely stolen over lunch because we discussed about this, consumer attitudes to ruminant products, but it was great to hear some of the views. And in fact, the really important point about price when we're looking at why consumers purchase ruminant products. It's absolutely essential, and there was some research done in a supermarket. I won't say which one it was, but every little helps. And actually, they looked at, they took 100 consumers as they were coming into the supermarket, and they asked them what they made their product purchase decision on. And the majority of them said quality. I buy the best quality. Those same retailers, as they came out of the supermarket, their shopping was taken away from them, not forcibly. And actually, they showed that the higher proportion bought on price, exactly. So what consumers say and what they do are completely different, so a real difficult situation. But there are other things associated with quality and what consumers perceive as quality and reasons why they buy. Food safety is taken as an absolute standard. And from buying food, it's safe. So it's not going to influence production or purchase decision. Nutritional value and colour shelf life certainly do influence purchasing decisions. Production methods certainly influence purchasing decisions. And then there's a whole others. Lifestyle, the way we actually consume animal products. Can I have 30 minutes, not 15? Animal welfare, exploitation, health aspects of animal products. Alternative to animal products, I usually have a bit of a slangy match about vegetarian, but Pete's very nice, so I'm not going to actually say that. Although, environmental impact and also food scares influence purchase decisions. So anything we actually do to our products influences purchase decisions, but the most important one is price. So we need to understand the control, and we had a good discussion over lunch about how we start to do that and how difficult that's going to be. So I'm here to talk about benefits of forage systems in terms of product quality. So is meat a high-fat food? No? It depends. It does very much depend on what you eat. But it's actually, it's a low-fat food. Lean meat, depending, and there's big differences again across breeds. Our Holstein Friesian has about 4% fat. Our Welsh Black has about 3%, and our double muscle Belgian Blue less than 1%. Doesn't taste of anything, but it's very lean. So it's actually not the fatty acid content of the product which is an issue. It's actually the composition of that fat. And here's the makeup of a typical meat. We have a neutral, monounsaturated, some beneficial aspects, and you hear more about that. You've heard some of that from Ian, and probably hear more from Kevin in a moment. Beneficial polyunsaturated, and then our saturated fats, which have had the negative press, particularly lauric and myristic acids. So how do we increase the polyunsaturated fatty acid profiles of our meat? Well, there's different sources of fatty acids, whole load of oil seeds, but the majority of fat going into ruminant-based diets, or at least it should be, is from forages. And forages are predominantly membrane lipids. So these are phosphogalactolipids, a smaller portion of triacyl and diacylglycerol. The reason why there are a high proportion of membrane lipid is that the lipid is predominantly in the chloroplast and of the thylakoids. Those thylakoids are made of these membrane lipids, and the makeup of those fatty acid profiles in the phospholipid is predominantly unsaturated, polyunsaturated fatty acids. The majority of the grass fats are alpha-linolenic acid, a polyunsaturated omega-3 fat. So that's what's going in. How come the product is highly saturated? And the reason for it is because ruminants are symbionts. The advantage we see of ruminants utilising fibre is their relationship with this microbial population, this fermentation chamber in the rumen, which allows them to take poor quality feed to produce fantastic, highly nutritious meat. But the issue is these same microbes find polyunsaturated fatty acids toxic. And so therefore they detoxify the fats, and they convert a polyunsaturated fat into a saturated fat. Now this is a very simple schematic showing fatty acids as they enter the rumen. They can be presented in two forms. They can be cell-bound or they can be free. Because remember, animals grazing, a proportion of the cells will still be living. They won't be completely ruptured. There'll still be a proportion which will be intact. And they will then go through plant-mediated breakdown of that lipid and that protein. But anyway, the fat within the rumen is biohydrogenated. And it's biohydrogenated to a relatively high level. Well, a very high level. In fact, you lose 92% of your alpha-linolenic acid, your 18,3, and 86% of your 18,2. So these bacteria cope with that PUFA by saturating it. That's why you produce a high saturated product from a basis of putting high PUFA in. There are numerous strategies, and I know Kevin's going, where's Kevin? I'm not going to steal your thunder, Kevin, well, maybe a little bit. So there's numerous strategies which can influence biohydrogenation. Fish oil, red clover PPO, plant secondary metabolites, protozoa, green odour. All of these have an influence on biohydrogenation in a complex way, which Kevin, the proper scientist, is going to talk about in a moment. I'll concentrate on a plant strategy, red clover polyphenol oxidase. Breeding plants to improve the nutrient availability into animals. Red clover has a if you feed red clover as opposed to grass, the same level of substrate supply, so you provide the same amount of 18.2 or 18.3 from grass or from red clover, you will have a higher proportion of 18.2 and 18.3 in the milk or meat off red clover. And the reason for that, there's numerous reasons for that, but one of the potential reasons for this is we believe it's to be the enzyme polyphenol oxidase. Who here has experienced polyphenol oxidase? Everyone. Anyone who's had banana sandwiches particularly, you know, lovely when you start them and then just black mush. Why your mother gives you banana sandwiches, I don't know. But so this enzyme system has a mechanism to actually complex protein. And in the complexing of protein, it can encapsulate and entrap lipid, and therefore protect some of that lipid as it moves through the rumen. So here is a plant-based strategy which can increase product value, not only nitrogen use efficiency, but also in terms of polyunsaturated fatty acids. But forage feeding will also result in greater levels of omega-3 long-chain polyunsaturated fatty acids. As you supply more alpha-linolenic acid, more of that will move through the gut, and you'll have desaturation and elongation reactions in the liver. So feeding a high forage diet here in green will result in products with higher levels of these beneficial long-chain fats. So forage feeding, good news in terms of beneficial fatty acids within your products. Oh, Lord. Okay, so if you've got higher levels of polyunsaturated fatty acids, there's also, I nearly mentioned it, forgot to mention this, there's also some interesting unique fatty acids associated with pasture production. Phytanic acid, which comes from chlorophyll metabolism, and Romanick acid, cis-9 trans-11 CLA, which comes from biohydrogenation when it's moved down the forage route. And Kevin will talk more about that. Thank you, Kevin. So if we have high levels of polyunsaturated fatty acids in our ruminant products, one disadvantage of this would be is you have greater oxidation. Polyunsaturated fatty acids are more prone to oxidation. So therefore, a pasture-fed system would have lower shelf life because it's more likely to get rancid. Incorrect. Forage-fed animals would actually result in steaks which have a higher shelf life, even though they have higher levels of polyunsaturated fatty acids and more prone to oxidation. Why is this? Because those PUFAs naturally exist within the membranes of the plant tissue, and they're protected by their own natural antioxidants, vitamin E, alpha-tocopherol. So when the animal consumes the high levels of PUFA from pasture, it also consumes the natural protection mechanism, which is vitamin E. So actually you'd have an increased shelf life from a forage-fed animal than a concentrate-fed animal. And there's the proof in terms of colour differences. These are loin steaks aged for 10 days and displays for 14 days. Big difference between the forage and the concentrate. We're talking a discussion about waste. Another part of the argument in terms of carbon is how long that product is viable on the shelf. This should be an important point about the product. So a forage-based system which has a higher shelf life is more beneficial in terms of actually the carbon capture from that. This is a really important aspect in research that we're carrying out at Northwick, looking at the LCA of beef production. Understanding that there's lots of impacts and values of beef production off pasture, and we want a way to be able to capture those. So we're taking these animals off our 3 systems at Northwick, all the way through, and looking at the true impact and carbon balance, all the way through to research on the meat quality and the shelf life of that meat. And I think that's absolutely vital to capture all that. Where can you do this research? There's only one place you can do this research, and that's at Northwick Research, because of our fantastic farm platform. I feel like a salesperson now. Fantastic farm platform in terms of research capability. Remember, this is a national capability and open for research. Finally, as a point I think made about sustainability within the UK, we can't address global food security in the UK. We have to look at sustainability across the globe and look at the position of ruminant livestock as a vital provider of food globally. And the only way we can do this is a global network of farms based on different systems in different climatic zones. And this is a research project which I lead with Mark Eisler from the University of Bristol, all about sustainability in different parts of the planet linking up. So if you have the time, please go onto that website. Thank you.
Thank you so much. Brilliant. And you kept in time.
Well, I sped up a bit.
So now we've got Kevin Shingfield from the University of Aberystwyth. Same theme, benefits of forage systems on product quality, but this time mechanisms and implications. Kevin.
Thank you very much. I'd like to also thank the opportunity to come and speak to you today, and also the Sustainable Food Trust for organising this meeting. Michael's done a good job of giving me a good lead into some of the things I want to talk about. But if we consider ruminant foods and we consider the motivations as to why people consume these foods, I think the first point to make is that they are desired foods. People want to eat them. They contain proteins that are of high biological value, and we know that these foods are also a source of bioactive lipids and have a role in the maintenance and prevention of chronic disease, the maintenance of health and prevention of chronic disease, and they're also rich in micronutrients. But on the downside, they're known to be quite rich in saturated fatty acids, particularly the medium-chain fatty acids, palmitic acid in particular, which is a known risk factor for coronary vascular disease. They also contain trans fatty acids, which are also known to be a risk factor for cardiovascular disease and also the onset of insulin resistance. And of course, as we've heard this morning, there is concern about the production of these foods as it relates to their environmental footprint. But if we go on to actually consider some of the effects of grazing on some of the nutritional value and nutritional characteristics of these foods, what we see is that grazing, when we compare it to the production of foods either from conserved forages or from high concentrate systems, we tend to find that the products will contain higher amounts of carotenoids and tocopherols. We'll find that the concentration of polyunsaturated fatty acids, particularly linolenic acid, will be higher. We know that these production systems result in a higher concentration of Romanick acid, and we know that under normal circumstances they will also lower the concentration of the medium-chain fatty acids, the excessive consumption of which has been linked with an increase in cardiovascular diseases. Similarly, if we look at, this was for milk, if we look at beef or sheep, we find pretty much the same sort of types of changes in terms of higher concentrations of the fat-soluble vitamins. We find that with meat we'll get a lower N-6 to N-3 polyunsaturated fatty acid ratio. We find that also in beef we will increase the concentrations of the very long-chain omega-3 fatty acids, and we also see an increase in the amount of conjugated linoleic acid, particularly Romanick acid. So if we try and actually put these changes in some sort of context, and I put this slide up here just to remind ourselves of actually what the situation is in terms of one of the most prevalent chronic human diseases. If we think about coronary heart or coronary vascular disease as it relates to heart disease or strokes, it is the leading cause of death worldwide. And interestingly, most of the increase in these diseases is now occurring in the developing countries, particularly places such as India and China. This is where the highest rate of increase in these diseases is occurring. And some estimates of the cost of these diseases. Some years ago, for the EU 25 states, it was estimated that the direct and indirect costs of coronary vascular disease was 200 billion euros per year. In the US, it's estimated to be about $400 billion, and in India, it's about $240 billion. In terms of the costs of treatment, but also people not being able to work. Now, before the financial crisis, people used to think this was a lot of money. These days, what we see is that the national budgets of most governments, the projections are these diseases will increase, and we simply will not have enough money to begin to treat or deal with the direct cause of the disease and the consequences in terms of loss of labour to the market. And what we know about trans fatty acids and health, you're probably aware of some of the issues surrounding trans fatty acids, but they are thought to be particularly harmful in terms of their effects on coronary heart disease risk, particularly because what they do is they elevate the concentrations of the LDL cholesterol, so the bad cholesterol, if you will, become elevated, and the concentrations of the good or protective cholesterol, HDL, are lowered. There is also some evidence that excessive intake of trans fatty acids also is a risk in terms of inflammation and the onset of sudden heart attack. Unfortunately, where we are with this, the evidence is still rather scant in terms of understanding which particular trans fatty acids are harmful. And we know that all sorts of foods contain a variety of different trans fatty acid isomers, but we're not yet sure exactly which ones are the most harmful with respect to onset of chronic disease. Just a quick mention about Romanick acid. Romanick acid, or cis-9-trans-11, CLA, it predominates in milk, dairy products and ruminant meat. Certainly meat and dairy products are the largest source in the human diet, and there's quite a body of evidence using rodent models to suggest that this particular compound is a very potent anti-carcinogen. And certainly some of the early studies that were done that feeding a high CLA-rich diet to rats actually physically caused mammary tumours to regress. So not only just arrest the growth of these tumours, but actually to cause the regression. So it's a very, certainly in these animal model studies, it's been shown to be a very potent anti-carcinogen. The challenge we have is to extrapolate, first of all, the doses fed to these animals and what it would actually mean in terms of how much we would need to eat to get the cancer-protecting effects. Most estimates suggest that we would actually have to double our current CLA intakes to sort of reap some of those benefits. There is some anecdotal evidence in terms of milk and dairy food consumption being inversely related to the incidence of breast cancer, for example, but unfortunately we don't have any hard clinical data to support an anti-carcinogenic effect of Romanick acid in humans. And just to touch upon the long-chain N-3 fatty acids, we know that they're very important in terms of lowering cardiovascular disease risk. They have very sort of good protective effects on heart muscle. They are also involved in sort of alleviating some of the etiology in terms of the development of arterial plaques. And there is some sort of evidence to suggest that they're involved in development of cognition in the infant and have positive effects on immune function. So if we just step back for a second and I sort of go back to the changes we see in meat and milk from pasture, you will see that many of the changes we see in terms of the nutrient composition are at least consistent with some of the positive effects identified either in human studies or in animal model studies. So I just wanted to put those changes in context as it relates to human health related outcomes. So we know that grazing has these effects, but the question is, how does it all work? And actually Michael sort of stole my thunder a bit here, but at least it gives you a second opportunity to revisit lipid metabolism in the rumen of a ruminant animal. But essentially we have dietary lipid coming in through the mouth, and we have a flow of fatty acids coming out of the rumen, available for digestion and absorption in the mesum and small intestine. And essentially the process is that the first step, most of the dietary lipid eaten by a ruminant is esterified. It goes through a process whereby the ester bond between the fatty acid and primarily the glycerol backbone is broken down in a process called lipolysis, and the free fatty acids that are liberated are then actually chemically isomerized and reduced. And the reason for this, as Michael said, is to reduce the toxicity of these fatty acids on bacteria, particularly those involved in fibre digestion. But as a consequence of this process, there are a number of outcomes as it relates to the quality of ruminant foods. The first thing is that we see a major disappearance of the essential polyunsaturated fatty acids from the rumen. We do get some formation of some of the conjugated linoleic acid isomers in the rumen, but we also get the production of a number of trans fatty acids because the process by which these polyunsaturated fatty acids are completely reduced to stearic acid is incomplete, and we get a range of these different intermediates accumulating. Now, when we go to think about pasture, there have been a number of sort of working hypotheses put forward as to why we see the effects that we do. So if we just think about the generalized effect of feeding pasture as opposed to conserved forages or high concentrate diets in a ruminant animal, the first thing that we will see is there'll be more esterified lipid escaping the rumen, and this is mainly the vehicle by which polyunsaturated fatty acids leave the rumen and are incorporated into meat and milk. We also see an increase in trans fatty acids coming out of the rumen, and as I said, we get the higher amounts of PUFA coming through from the esterified lipid, or extra esterified lipid. There have been a number of hypotheses put forward to explain or potentially explain these effects. One of the working hypotheses, and this is some work that Michael was involved with when he was in Aberystwyth, relates to green odour compounds. So these are compounds that are actually released during the mastication or breakdown of the plant tissue. These volatile components are actually released, and it's proposed that they could go on to actually affect the microflora in the rumen and go on to actually affect either lipolysis or the biohydrogenation process itself. There is also a school of thought that actually, 5 minutes. There's also a school of thought that perhaps plant lipolysis, the lipolysis process that occurs within the plant, may actually have a bigger role on grass than when we feed diets on conserved forages. And there is also some evidence to suggest that chloroplast, which is where most of the polyunsaturated fatty acids are within the grass cell, could actually be ingested by protozoa and thereby escape the process of lipolysis and biohydrogenation, and therefore effectively be a bypass mechanism whereby some of these essential fatty acids can escape the rumen. And as by way of evidence, this is actually a picture of a protozoan here that's been harvested from the rumen of a steer-fed fresh grass, and you can see that within the body of the protozoan, you can see there are a lot of ingested chloroplasts. So at least we know that the protozoan does certainly ingest chloroplasts, which gives some credence to that particular working hypothesis. The other issue, I said that pasture certainly increases the amount of trans fatty acids in these foods, but when we think about trans fatty acids, it's very, very important we also consider the distribution of different isomers. So if we look here at a collection or a range of trans monoenoic fatty acids, what you'll see is there is a very distinct distribution, and trans 11 or vasenic acid is generally the major isomer in these particular products. If we compare that to industrial fat or hydrogenated vegetable oil, you'll see the isomer profile is very, very different. It's much more homogeneous as opposed to what we see in ruminant fat. And it's been argued that because of this very different isomer distribution, the biological effects of these two different sources of trans fatty acids is very different. There is some evidence to suggest this might well be the case. We certainly know that a lot of the vicenic acid, about 30% of this is converted to rumenic acid in humans. Rumenic acid, of course, I mentioned, may have anti-carcinogenic effects. But the other point I would like to say is that if we rear our beef on a very high concentrate system, we end up with a trans fatty acid isomer distribution that's very similar to hydrogenated oil. We end up shifting, whoops, you can't see it, you end up shifting from this being the predominant isomer to actually a sort of equal distribution of vicenic acid and trans 10. So we know that feeding system has a major impact on the distribution of these particular isomers, but the impact on human health remains unclear. Just to talk briefly about CLA synthesis in the ruminant. Rumenic acid is the major CLA isomer in meat and milk from ruminants. There are about 32 different isomers in meat and milk. The reason rumenic acid is so abundant, or relatively abundant, relates to the biohydrogenation process being incomplete. We produce an isomer, vicenic acid, in the rumen. This then is absorbed and is actually desaturated by sterile CoA desaturase, either in adipose or in the mammary gland, and this is what gives rise to the high amounts of rumenic acid. So about 85% of the rumenic acid in milk will actually be coming from endogenous synthesis in the mammary gland. So not from the rumen, but actually from the mammary gland, for example. There's also another isomer that's exclusively synthesized endogenously, and just to complete the story, there's also evidence from last year that actually vicenic acid can be produced in adipose. So what are the implications? The implications are that perhaps can we enhance these attributes? Can we enhance the characteristics of what makes grazing so special? So could we go through a program, and in fact we are in Aberystwyth at the moment, looking at trying to select for certain characteristics of grasses that would actually help us to further differentiate, if you will, products from pasture from other production systems. So, you know, things like producing a high lipid grass, for example, is something that we're actively working on at the moment. My colleagues working in the Rumen Systems Biology group are looking at things such as targeted antimicrobials or other volatile agents to modulate what goes on in the rumen. And of course we've always got the option of actually looking at animal breeding, whether it be optimizing animal genetics for grazing, whether it be trying to select for various enzymes or various genes encoding for key enzymes within animal tissues or the mammary gland, or actually sort of developing a program to select for rumen lipid metabolism. So on that note, I'd like to say thank you very much.
Thank you so much, Kevin. And our last speaker is Professor Mark Eisler from the University of Bristol. His theme is Spilt Milk Worth Crying Over. Was that one of Richard's, or was that yours, Mark?
I think that might have been my fault, I'm afraid. I apologise for that before I start. So I wasn't entirely sure what Richard wanted me to talk about today, and I'm still not sure whether I know what I'm going to talk about, but I will try to just give you the benefit of a few of my thoughts on this. Sorry, are you able to get that to appear for me? Thank you. Yes, so I'm probably not going to show you very much data now, or too many biochemical pathways. I hope you'll be pleased to hear that, but basically just some sort of general thoughts about this area. One of the things, I haven't been to a meeting for a long time about this sort of thing without somebody or other showing this slide. It hasn't appeared yet today, so I thought I'd better put it in. But Planetary Boundaries, people are increasingly concerned about these. Climate change is one of the sort of headlines for this meeting, but I think it is just important to re-emphasize the point that it's only one of the challenges that we face as a planet and a species, and that things like biodiversity loss and nitrogen and phosphorus cycles are actually also important and in some ways perhaps even more acutely of concern. So that we need to bear in mind that there is this sort of wide range of things. And also perhaps just to revisit the growing human population of the planet. So to use Hans Rosling's so-called global pin code of the approximate population of the Americas, Europe, Africa and Asia, so 1114 representing those 4 continents, our present 7 billion people. According to Rosling, this may be expected sometime after 2050 to plateau out somewhere in the region of 1145. So essentially a 4-fold increase in the population of Africa and a fairly significant increase in Asia, little in Europe or the Americas. So we had a little bit of discussion about Africa earlier, and in fact, coming into my topic about spilt milk and cattle, and the black and white cow is a centerpiece of this. Holstein cattle, in fact, it came to my attention over a number of years that I worked in Africa. They've been imported there in huge numbers, both actually as sort of whole live animals and also by artificial insemination, also to Asia for the benefit of very large milk yields. But these are animals that have bred for intensive management in temperate climates and have sometimes been described as the world's least fertile farm animal. And in fact, I see these as an example in these tropical climates as a species or genotype unsuited to its environment because they have poor resistance to heat and humidity, tropical diseases, parasites. In fact, you may spot one of this animal here has got something wrong with its eye. It's suffering from a tropical parasite I shall return to in a moment. So these things are associated with huge additional costs. The animals get sick. They often have to be kept indoors and food cut and carried to them. The production is lower than expected. And overall, it may well be that the expenses and difficulty of having such an animal outweigh the extra income of this theoretical increased milk production. For many years, I actually lived and worked in Africa on this parasite you see in the bottom right here, the African trypanosome, transmitted by the tsetse fly, which has a very wide distribution in sub-Saharan Africa, and also, to some extent, on another parasite, Theileria parva, the cause of East Coast fever, transmitted by the brown ear tick, Rhipicephalus appendiculatus, which again has a very wide distribution in east and southern Africa. And this is actually the reason why that animal that you saw there had a discoloured eye, because it was suffering from this particular parasite in a dairy farm in Uganda. But I'm not going to dwell on Africa, but having discovered about the unsuitability of these animals for that climate, when I started working increasingly in the UK, I became concerned about the situation with milk and the dairy industry, and was alarmed to discover that it's the 3rd most wasted of the 4.2 million tonnes of food that we waste per year in the UK, and that there's a very large quantity of avoidable dairy and egg waste at a cost of the best part of £1 billion. And people tend to regard milk now as very much a throwaway commodity. Why is this? Well, it's so incredibly cheap, isn't it? We don't need to sort of mention anything but the sort of usual suspects, perhaps. And extraordinarily cheap. I know of no other liquid that I might want to buy that is available so cheaply. You know, this comes out to something in the region of 22 pence a pint. When was beer last 22p a pint? A long time ago. So this is also partly due to the miracle of the modern Holstein cow. So there's a sort of Darwinian selection of dairy farmers and cattle. So we have a dairy industry now that is hugely efficient with fewer, larger herds, very few people working on a farm, minimized labor costs. We have this fantastic high-yielding, high-potential Holstein Friesian animal with over 10,000 litres of milk produced per year, arguably the perfect animal, a remarkable example of what can be achieved with sort of very selective breeding and the most efficient genetic approaches that have been used over the last century. So this wonderful animal can give us infertility, it can give us lameness, mastitis, metabolic disease, digestive disorders, infectious diseases, the use of a lot of routine antibiotic hormone treatments. So as a veterinary surgeon, this is a marvellous thing. It's one of the few reasons why vets actually get to earn a living by going to visit farms once or twice a week, to go and see a queue of cattle lined up at a crush where they've got one or other of these things, and they can usually be given some sort of antibiotic or hormone. Is this a good thing? Well, this prodigious yield requires a huge amount of energy and protein, far beyond the level available for mere pasture. So these animals now have to consume potential valuable human food. And a dairy cow eats more than its own body weight of cereals in a single lactation, which it's relatively ill-equipped to digest because, as you know, it evolves to eat pasture. So we have problems like subacute ruminal acidosis, displaced abomasum, and probably a whole host of other metabolic problems associated with this unsuitable diet, which is produced using large quantities of artificial fertilizer, and in fact negates the evolutionary advantage of the ruminant we've heard a lot about already, to digest forage and green waste and byproducts of low nutritional value to things like pigs or poultry or human beings. So there is a sort of strange dilemma with the dairy. Most of our animals are Holstein Friesians. Now, the other breed I have on this slide is an Ayrshire. I know that we have certain people here that are particularly fond of it, but it could be any one of a number of alternative breeds. The Holstein Friesian can produce something in the region of 10,000 kilograms of litre of milk a year. One of these other breeds might produce roughly about 75–80% of that amount of milk, but in so doing, it perhaps is an example of the Pareto principle, beloved of economists, the 80-20 rule, that suggests that perhaps you could get 80% of the yield from one of these lesser breeds with perhaps 20% of the cost. So, for example, the amount of nitrogen, inorganic nitrogen fertilizer that would have to be applied to the field to get the other 20% of the yield that we can get from these Holstein-type animals, it may be that we have to actually have a huge amount of more inputs on the farm in terms of use of inorganic nitrogen for concentrates and all these other sort of environmental costs associated with it. I'm not talking about greenhouse gas here. Greenhouse gas perhaps doesn't fit into this model, but I think it's just a sobering thought to wonder whether we are working with the right kind of cattle in our present system. So I have actually published this thought, and I've been told that I need to look at this paper by Judith Capper and others who compared 1944 dairying with 2007 dairying, and they pointed out that modern dairy systems produce 24% of the manure, only 43% of the greenhouse gases, and 56% of nitrous oxide per billion kilos of milk compared with the equivalent milk from historical dairying. Well, this is all very well and true, but if you look at the small print in this paper, in fact, there is a little bit of data here, I lied. So their 1944 animal, they're doing the comparison, is producing a mere 2,000 litres of milk. Well, I think that actually, if you go that low, it does stack the figures rather in favour of the modern system. But in fact, I think there is a compromise that might be had where, in fact, we may have animals that don't suffer from quite so many diseases and perhaps in some ways at least have lesser environmental costs, that don't need to produce quite so much milk that we're only going to end up pouring down the sink anyway because it's so cheap. And interestingly, a recent publication in the Journal of Dairy Science, just for example, showed that Holstein cows have higher production intake but lower efficiency than the Jersey when compared at the average production level of commercial herds, even before you start looking at the kind of system in which you're keeping these animals. But perhaps we should talk a little bit about the kind of systems we're keeping. And one of the things that's come to the fore in recent years is this idea of mega dairies. And I expect most people in this room were aware of the controversy a few years ago of the plan to build a very large 8,000 cow herd and then perhaps 4,000 cow herd at Nocton in Lincolnshire. And in fact, this application caused a huge amount of protests, say no to the factory farming and mega dairy, let's cross it out. In the end, the Environment Agency turned down this proposal on grounds to do with sort of local control of pollution, probably not the kind of things that campaigners were concerned about, like animal welfare, expression of natural behaviour, animal health and human health, antibiotics, hormones, greenhouse gas, all of these usual kind of sustainability and pollution issues, but particularly welfare, and perhaps this idea that people don't like factory farming. And in fact, forgive me for showing this slide, but we've had a lot of publicity about the Holocaust and the survivors of it. And I think there is an association. It was pointed out to me actually by one of my colleagues in the University of Bristol in the Department of Biosciences, Biological Sciences, that perhaps one of the fundamental reasons why people don't like this kind of thing is because these are our sort of fellow sentient creatures, and if we can do this kind of thing to them, perhaps there are other things that are sort of not so far away that we might do to each other. So I think there is a kind of fundamental aesthetic objection to factory farming that is often goes unstated. And I think we need to recognize it, we need to be cognizant of it and take it into consideration. France, again, in fact, they don't have any farms as big as ours. They don't have any 1,000-cow farms in France at all. The meal vache actually has only got up to 500 cattle, but already there are big protests. Maybe there's a sort of aesthetic quality associated with food, and the more you are concerned about the sort of aesthetics of food, the less you like this. I'm not sure. We heard a little bit earlier about TMR, exporting environmental footprint. I think this is just something I would like to again raise the profile of in this meeting about the amount of soy produced in South America. So these big dairy farms using the TMR, total mixed ration, rather than grazing. Are we exporting the problem? And at the other end of the spectrum, well, what's the alternative? We have people like the free-range dairy group who believe in grazing cattle and feeding them on grass or conserve forage throughout the year, and that perhaps one could produce a product of higher value that consumers would pay more for to make a sort of living wage for dairying. There's a contrast here. And benefits of pasture over monoculture are often considered. So this is another aspect, biodiversity, I think we're moving into. But interestingly, if you look at the small print, Nocturne Dairies have produced a sustainability statement and a cow welfare and management statement. And some of the issues here, if you look at the detail, in fact, it's remarkable how Nocturne ticks very many of the sustainability boxes and ticks very many of the animal welfare boxes. There's one area that perhaps remains, I think, in my mind, a bone of contention. That is freedom of these animals to express natural behaviour and to go outdoors and to graze. But it was a very, very well considered proposal, and I don't think one should rule it out of hand. So where does this lead us? Well, I think perhaps we come to this land-sparing, land-sharing argument. It's a question of, do we keep our animals and livestock intensively and have biodiversity and ecosystems provided in another area, or do we have a sort of integrated system? My suspicion is that perhaps the answer lies that we need to do both things in different places. And there's a nice example, a bit of modelling done by Callum Brown and others in Edinburgh, where they looked at, in fact, a theoretical agent-based model where their agents consisted of either conservationists or farmers, and the farmers might be high or mid or low intensity farmers. And if you populated a landscape where you had just two kinds of resources, either financial or natural capital, with these agents, they did partition out into a sort of land sparing model. So we have the conservationists at the bottom, where there's the greatest natural capital, and increasingly intensive farmers as you move up into the area of the greatest financial capital. Change the model a little bit into 4 quadrants, as you do in the bottom left here, and you see that the way the landscape partitions out is rather different. The 4 quadrants do not share food. Essentially, you end up with land sparing or land sharing and some set-aside landing, depending on whether the level of productivity of the area meets or exceeds demand. So I think that there are some basic theoretical ways of looking at this that are intriguing. And there we are, Patrick, that's the end. That's all I have to say.